Hi, this is Mrs. Hickman, and in today's video we're going to be looking at differential equations. So there's two types of differential equations. They're for finding a solution, there's a general solution and then there's an initial value solution. So first you're probably wondering what a differential equation is. Well, a differential equation is an equation involving a derivative. The order of a differential equation is the order of the highest derivative involved in the equation. So to find the general solution, the differential equation is called exact because it gives the derivative exactly. So how to find it? So that's going to be what the derivative is exactly, which is going to be why we're going to attach a constant c to the end. Okay? Because what you're going to see, you're going to find the antiderivative, so we're going to be taking we're going to integrate this, and you're going to get 5x. Well, what if there's going to be something aside from it? That's where that constant c comes from. So the derivative is going to be given, so dy over dx equals that. Then you're going to attach a c to the end of the antiderivative, and then you're going to find the general solution to find the exact differential equation. So, what you're going to do, so you're most likely, you're going to be multiplying this side by dx, so you get dy equals secant squared x plus 2x plus 5, multiply the dx up here, dx. Okay? Now you're going to integrate both sides. I didn't see that there, but you're going to see why here. So integrate both sides. Okay. The antiderivative of 1 is just y. Okay. So that could be like 1 times dy. That's why you get that. Alright, and then we're going to integrate this. So the antiderivative of secant squared x is tangent x plus 2x. So that's going to be 2x squared over 2 plus 5x, and then you add a constant c. So your final answer is going to be y equals tangent x plus x squared plus 5x plus c. That is your general solution. Alright, next one. So we have our derivative equals 1 over x minus 1 over x squared, where x is greater than 0. And you're going to see why soon. We know why x can't equal 0 because we have x's on the bottom, and to integrate something it has to be continuous over an interval. Well, we know it is. Okay? So multiply both sides by dx, so you get dy equals 1 over x minus 1 over x squared dx. Integrate both sides. Okay, so that's going to be y equals, I'm going to write them using negative exponents. So you got x to the negative 1 minus x to the negative 2 dx. But if you can remember, so if I want to integrate this, you're going to get x to the negative 1 plus 1 over negative 1 plus 1, which is 0. So you're going to say, well, I can't divide by 0. That's because 1 over x, or x to the negative 1, the antiderivative of that is going to be ln of x. And we're going to put an absolute value sign. Well, never mind, we don't have to because it's greater than 0. But if you want to get used to it, you could put absolute value of x. Minus x to the negative 2 plus 1 over negative 2 plus 1 plus c. So you get y equals ln of x. It's going to be greater than 0 because of this right here. Minus, minus x to the negative 1 over negative 1. So you get y equals ln of x plus 1 over x plus c. Okay? Negative times negative is a positive. X to the negative 1 is 1 over x. Try to keep positive exponents where you can. Okay. one more example. So this kind of relates to the chain rule in a sense. Okay, so we got our example here. So multiply by dx, so everything's the same there. So you get dy equals cosine of t e to the sine t dt. Okay, integrate. We're never going to get y here. Okay, however, this is a little bit more complicated. So let's look over here. So let's go back to our chain rule type thing. So if we were to find the derivative of e to the u, the derivative of finding e to the u is u prime times e to the u. So let's look over here. So u prime times e to the u. That means this is going to be in the form u prime times e to the u. So u prime is cosine of t. So you could do it two ways. So this could be cosine of t e to the sine t. Right there. So to go backwards, that cosine goes away and you're just left with e to the u, which is e to the sine of t. Okay, so the antiderivative of that is going to be y equals e to the sine t plus c. And you're done. Okay, a particular solution to an initial value problem. So if the general solution to a first order differential equation is continuous, then to find a particular solution, an initial condition of a given point must be given. So you're going to be given an x and y value, which you see right there. You're going to find the general solution, which is what we did up here with the plus c's. After you find the general solution, you're going to plug in your x and y value from your point. So this is going to be x, that's going to be y. And then you're going to rewrite the general solution with your, use x and y, and then you're just going to solve for c. And then you're going to write your particular solution with your general solution in part c. Sounds complicated, but it's not. So first things first, nothing's changing. We're going to find the general solution here. So multiply by dx on both sides. So you get dy equals e to the x minus 6x squared dx. Integrate. So you get y equals the antiderivative of e to the x. Then you have 6x cubed over 3, which is going to be 2x cubed. Plus c. That is your general solution. So now let's find a particular solution. So to find a particular solution, we're going to put y equals 0 and x equals 1. So we're going to have y, so you got 0 equals e to the 1 minus 2 times 1 cubed so you get 0 equals e minus 2 plus c. So c is going to become, subtract e plus 2, negative e plus 2, or you could say 2 minus e. So your final answer is going to be y equals e to the x minus 2x cubed plus, or minus e plus 2. So e to the x minus 2x cubed, and c is minus e plus 2. Okay. Final example. Let's better look. Okay, multiply by dx on both sides. Integrate. Y equals, so you got 10x to the 9 plus 1 over 9 plus 1. So that's going to be x to the 10th plus 5x to the 5th over 5, which is x to the 5th, minus 2x squared over squared, which is going to be x squared plus 4x plus c. Okay, so I just did the power rule for each of those. Y equals 6, x equals 1. So where you see y, put a 6. Where you see x, make a 1. Okay. 6 equals 1 plus 1 is 2 minus 1, which is 1, plus 4, which is 5. Subtract 5, c equals 1. So your final solution, or your particular solution, is y equals x to the 10th plus x to the 5th minus x squared plus 4x plus 1. This ends the video for general solutions and particular solutions, or initial value problem, for this section right here. So I guess I should say that before I go. So a particular solution is also an initial value problem. And we